Hello everyone. Today, let's explore the topic solar eclipse, a marvelous astronomical phenomenon and its scientific significance. Throughout history, humans have always been captivated by mysterious phenomena in the sky. One of the most fascinating and spectacular events is the solar eclipse, the moment when the sun is swallowed by darkness in broad daylight. Ancient civilizations once saw solar eclipses as divine omens, but modern science has shown that this is a completely natural astronomical phenomenon that can be explained, observed, and accurately predicted. More than just a curiosity, solar eclipses provide great value in the study of the universe and the operation of celestial bodies. This video aims to present a comprehensive and easy-to-understand explanation of the nature of solar eclipses, the different types that occur, their formation mechanisms, their cultural and biological impacts, and their scientific value. Let's dive in and discover together. What is a solar eclipse? A solar eclipse is an astronomical phenomenon that occurs when the moon moves into a position between the Earth and the Sun, blocking all or part of the Sun's light from reaching the Earth. This event can only happen during the new moon phase, when the moon lies on a straight line between the Sun and the Earth, with its illuminated side facing the Sun and its dark side facing the Earth. However, a solar eclipse does not occur every month even though there is a new moon, because the moon's orbit is tilted about 5 degrees relative to the ecliptic plane, the plane of Earth's orbit around the Sun. This tilt causes the moon to usually miss the Sun, passing slightly above or below it when viewed from Earth. From the perspective of celestial mechanics, a solar eclipse is the result of an eclipse of 3 celestial bodies in a straight line. Although the moon is much smaller than the Sun, with a diameter of only about 3,474 kilometers compared to the Sun's 1,392,000 kilometers, its much closer distance to Earth, approximately 384,400 kilometers on average compared to the Sun, 150 million kilometers, makes the apparent size of the moon and the Sun from Earth's viewpoint nearly equal, 0.5 degrees. This near match in apparent size allows the moon to cover the Sun almost perfectly, an ideal condition for the occurrence of a solar eclipse. During a solar eclipse, the moon casts 2 types of shadows as it blocks sunlight: umbra, the region where sunlight is completely blocked. Only observers within this area can witness a total solar eclipse. Penumbra, the region where the moon blocks only part of the Sun's light. Observers in this area will see a partial solar eclipse. If the moon is too far from the Earth during the new moon phase, its apparent disk will appear smaller than that of the Sun, making it unable to completely cover the Sun's light. This results in an annular solar eclipse, where the Sun's light remains visible as a glowing ring around the edges of the moon. A solar eclipse is not only a visually fascinating event, but also an important subject in various scientific fields, from astronomy, space physics, and geology, through measurements of geomagnetic fluctuations, to history and archaeology, as eclipses were recorded in many ancient civilizations such as Egypt, China, and Babylon. It also plays a significant role in education, helping people visualize the dynamic positional relationship among the 3 fundamental celestial bodies essential to life: the Sun, the Earth, and the Moon. Solar eclipses are classified into 4 main types based on the extent to which the moon covers the Sun and the observer's relative position on Earth. Below is a detailed breakdown of each type. Total solar eclipse. This is the most spectacular and rare type of solar eclipse. A total solar eclipse occurs when the moon is close enough to the Earth for its apparent disk to be equal to or larger than that of the Sun, completely blocking the Sun's light in a narrow region on Earth. The area where this phenomenon can be observed is called the path of totality, which typically spans only a few dozen to a few hundred kilometers wide. During the total phase, the temperature drops rapidly, daylight vanishes, and stars and planets may become visible in the sky. This phenomenon also allows for the observation of the corona, the sun's superheated outer atmosphere, which is usually invisible under normal conditions. Partial solar eclipse. A partial solar eclipse occurs when the moon covers only a portion of the sun's disk. In this case, the sun appears as if a bite has been taken out of it. This is the most common type of solar eclipse and can be observed in areas outside the path of totality. The degree of coverage depends on the observer's geographic location and the timing of the observation. Although it is not as dramatic as a total solar eclipse, a partial eclipse still holds scientific value, particularly in measuring the moon's orbital parameters. Annular solar eclipse. An annular solar eclipse occurs when the moon is at a farther than usual distance from the Earth, making its apparent size smaller than that of the sun. As a result, when it passes in front of the sun, the moon is not large enough to completely cover the solar disk, leaving a bright ring of sunlight, often called a ring of fire, visible around the edges of the moon. This phenomenon can be observed along a narrow strip called the annularity path, similar to the path of totality in a total solar eclipse, but without a total phase. Although the overall light level doesn't drop as dramatically as in a total eclipse, the striking ring of fire creates a very unique and captivating sight. Hybrid solar eclipse. This is the rarest type of solar eclipse, where the eclipse transitions between annular and total depending on the observer's location. The phenomenon occurs due to the curvature of the Earth. At some points along the moon's shadow path, observers see an annular eclipse, while at others, a total eclipse is visible. Because of slight variations in the distances between the celestial bodies and the effect of Earth's curvature, this type of eclipse lasts for only a short time and appears infrequently, making it a particularly fascinating subject of interest for astronomers. The phases of a solar eclipse. A solar eclipse, especially a total or annular eclipse, unfolds in several distinct stages, which can span over a period of time depending on the type and observer's location. First contact. This is the moment when the moon first touches the edge of the sun's disk. A small notch appears on the side of the sun. Sunlight begins to gradually decrease, though it is still intense enough that the change may not be noticeable to the naked eye. At this stage, specialized solar filters are required for safe observation. In both total and annular eclipses, first contact marks the beginning of the partial eclipse phase. Partial phase. After first contact, the moon's shadow continues to move across the sun's disk. Daylight begins to noticeably dim. If weather conditions are favorable, observers may notice environmental changes, such as softer lighting, a gentle breeze, and animals behaving as if it were dusk. Depending on the type of eclipse, this phase can last for several minutes to even tens of minutes. Totality or annularity phase. If it's a total solar eclipse, when the entire sun's disk is covered, the event enters the totality phase, the most spectacular part. The sky darkens dramatically, and stars and bright planets like Venus and Mercury may become visible. The solar corona, with its rays extending from the sun's edge, becomes clearly visible. If it's an annular eclipse, then at maximum eclipse, the ring of fire appears. The moon sits in the center, surrounded by a brilliant circular rim of sunlight. Both of these phases last only a few seconds to several minutes, depending on the orbits and the observer's location. Third contact phase. After the maximum phase, the moon begins to move away from the center of the sun's disk, and sunlight starts to return. This marks the end of the totality or annularity phase and transitions into the second partial eclipse phase. Many observers describe this moment as the diamond ring effect, when the first burst of sunlight shines like a bright flash at the edge of the moon. Last contact phase. This is the moment when the moon completely moves away from the sun's disk, marking the end of the solar eclipse. The sun returns to its original shape, and normal daylight is fully restored. Although no further astronomical phenomena occur after this point, many instruments will continue collecting data on the eclipse's spectrum and radiation throughout the entire process. Scientific value of solar eclipses. A solar eclipse is not only a visually stunning phenomenon, but also a valuable opportunity for scientists to observe and study hard-to-reach features of the sun. During total solar eclipses, the sun's corona, a faint, outer atmospheric layer usually overwhelmed by the sun's intense light, becomes clearly visible, allowing scientists to examine its structure, temperature, and magnetic field. Moreover, one of the most famous pieces of evidence supporting Einstein's general theory of relativity came from a solar eclipse in 1919. At that time, astronomer Arthur Eddington observed the bending of starlight as it passed near the sun, confirming that gravity can bend light, a key principle of Einstein's theory. Additionally, scientists use solar eclipses to accurately calculate the moon's orbital cycle, monitor gravitational effects, and improve orbital prediction models. Since ancient times, solar eclipses have been perceived by humans as supernatural phenomena. Many ancient cultures, such as those in China, India, and Babylon, believed eclipses were omens of disaster, war, or the wrath of the gods. In China, legend has it that a celestial dragon was devouring the sun, and people would beat drums and create loud noises to scare it away. Beyond religious interpretations, solar eclipses also affect the behavior of animals and plants. Many birds return to their nests, insects stop chirping, and some plants close their leaves as if night had fallen. The sudden change in light can especially impact human psychology, evoking feelings of excitement, wonder, or fear. However, it's important to note that looking directly at the sun, even during an eclipse, can cause serious retinal damage if proper protective eyewear is not used. A solar eclipse is one of the clearest demonstrations of the universe's wondrous, precise, and consistent workings. Once a phenomenon shrouded in fear and myth, a solar eclipse has now become a special opportunity for humanity to expand its understanding of astronomy, physics, and life itself. Through it, we can more deeply feel the connection between humans and the cosmos, a profound relationship that encourages us not only to observe but also to learn and reflect on our place in this vast universe. Understanding solar eclipses is also a step forward on the never-ending journey of exploring the mysteries of the heavens and earth. Thank you for watching the video. Don't forget to subscribe and turn on notifications to catch the latest amazing content.